Welcome to Mensan Musings Monday of the Petro Papers podcast. As you know, I love alliteration. It's been a few weeks since I did a musings. I've done a few episodes on this, and now I'm on to my fifth episode of the Mensan Musings, and I'm going to talk about hydraulic fracturing. It's been quite a crazy last few weeks in terms of my job status and starting a new business and also trying out different ventures and really going to revamp the Petro Papers podcast. So today I'm going to resume Mensan Musings Monday and discuss hydraulic fracturing. And we're going to do a high-level overview of hydraulic fracturing and then jump into the latest technologies and innovations in hydraulic fracturing that we can muse about. So for those of you who don't know hydraulic fracturing or that are new to petroleum engineering and that are listening and that happen to have stumbled upon this podcast and listening to this for the first time, let me give an overview of what hydraulic fracturing is. Hydraulic fracturing is the process of perforating your wells or perforating zones, shale zones, and then injecting fluid and chemicals. So fluid means like slick water, chemicals, and sand into zones to prop those fractures and to stimulate particular wells in order to provide production into tight zones, such as shale zones. Now, when you picture this in hydraulic fracturing, imagine like a horizontal wellbore or horizontal tube in a really tight zone, and then you poke holes in it. And when you poke holes in it, you start injecting a bunch of water, sand, and a bunch of chemicals in order to keep those fractures open. And then after we hydraulically fracture those wells, we flow back those wells in the hopes that the sand stays in the fractures, but we take back the water in order for us to continue that production or to start that production of those particular wells. So that's hydraulic fracturing in a nutshell. I got some feedback from my husband on these Mensan Musings Mondays, and I also decided to make use of Copilot to give me what are some of the latest innovations in hydraulic fracturing. I have some of my own, and then I'm also going to use what Copilot is reminding me of in terms of the latest innovations of hydraulic fracturing. The first thing I'd like to talk about is the fracturing of multiple wells at once. We've heard a lot about zipper fracking where it started off with zipper fracking where you frack two wells at a time, and then when I say two wells at a time, you fracture one well and then you fracture another well, so that's like simul-frac. And then you've heard about some other companies trying triple frac where you fracture three wells at a time. And the process of that is really complicated, and I could put more, it's not complicated, but I can put more into the description box below for our viewers and listeners, where you're fracturing three wells or zippering three wells at once in the different wells, and they could be of different zones and they could have different completion styles. That's supposed to increase efficiencies significantly, and there's like an economies of scale whenever you're triple fracking. So the benefit of that would be that when you're just fracking your wells faster, so you're spending less time in the field, and you're more likely going to increase your efficiencies and reduce the amount of rig time that you have on that particular well that you're stimulating. So those are some of the benefits. And no, Copilot did not teach me that. I was actually going to talk about simul-frac and zipper frac, and then triple frac. So, like I said, the original zipper frac is like using one well and you're zippering one well at a time. Simul-frac is fracking two wells at a time, and then triple frac is fracking three wells at a time, like zippering three wells at a time. Another thing I'd like to talk about, and there's so much we can talk about related to hydraulic fracturing, but I'm going to go more into detail for certain topics, and that one of them is automation and digital integration. So automation and digital integration is you're trying to automate hydraulic fracturing, and Halliburton has done this with a particular company on fully automating hydraulic fracturing, where you automate your zipper frac, your triple frac, or your simul frac. So that's with very little human intervention. So while it is meant to optimize frac design, it's also meant to be using an agnostic way to fracture your wells. Another thing that I would talk about is refracturing. For some reason, refracturing has made a comeback. I shouldn't say for some reason, I say in all good reasons, refracturing has made a comeback. Refracturing has made a comeback in hydraulic fracturing because there are there have been some there have been some evidence to see that there is a cheaper way, there's a faster way, there's a better way to refract our wells. A lot of the previous refracking technologies that you've seen in literature and that I've claimed that have not worked for in the Permian Basin in particular is that you're bullheading a lot of your fractures instead of using a liner. So when you're using your liner, you're increasing your precision at where you're going to refract your wells. So I should take a step back and really talk about what refracturing means. Refracturing is the process of having an existing hydraulically fractured or produced well, and then you're going in between fractures, and then you're perforating those wells, and you're doing the same thing where you're injecting chemicals, and you're injecting water, and you're injecting sand. So that is meant to enhance the stimulation of that particular well or enhance the production of that particular well. But now refracturing has been making a comeback, especially in the Permian, and continues to make a comeback in the Bakken for a lot more older vintage wells. The most success I've seen refracturing done is in the Eagle Ford and some in the Bakken as well. So there's lots of work being done in identifying underperforming wells, identifying what are the cutoffs in particular basins for refracturing. The next thing I want to talk about in terms of hydraulic fracturing advances in technology is using cleaner frac fleets or using EFRAC. So EFRAC has been going on for quite some time, for several years, but I think there's a push for lower emissions, there's a push for a lower carbon footprint. So instead of a diesel frac fleet, you would use a cleaner electric frac fleet. And it reduces carbon intensity, reduces those emissions, and especially in the Permian where EFRAC is becoming a lot more economic to use, especially with the economies of scale of using more EFRAC fleets compared to your diesel frac fleets. There's also a discussion on water reuse and water management. So water reuse is becoming a lot more important, especially in water strained areas like in the Permian Basin, or when I say strained in terms of clean water. But there are closed loop systems that are being used for water reuse, and there's also advanced treatments and chemicals and biocides in order to improve the frac water and improve the produced water quality to continue fracking into those wells and to reduce the lack of compatibility between frac waters or between produced waters and in situ waters. So what do I mean by all that? What I mean is the produced water that you end up getting whenever you're producing from your wells, they have a lot of bacteria, they have a lot of crap, to say the least. And you want to improve the compatibility of that water, so you would input chemicals in those particular produced waters in order to improve the compatibility or to reduce emulsion or to reduce the creation of crap, for lack of a better word, downhole. That way you're not plugging up and you're not pressuring up your wells unintentionally, or you're not screening out your wells. And screening out your wells is that is a spike in pressure in it due to sand blockage, sand bridging, or due to some kind of blockage downhole in your perforations. Then the last thing I'd like to talk about in terms of hydraulic fracturing is like how we're using real-time fracture optimization. So what I'm saying is, by using real-time frac data and making real-time on-the-fly changes, hydraulic fracturing has made a lot of leaps and strides in terms of how do you agnostically improve your fracs? Do we skip stages? Do we have to improve? How do we improve our hydraulic fracturing techniques on the fly rather than just committing to one design for all 50 stages? You have complex geology throughout your 2 mile, 3 mile, 4 mile lateral, or even your U-shaped lateral. How are you going to improve your frac well performance by creating customized designs for your stages? So I think using the real-time monitoring is going to be extremely important. So that's a lot of the stuff that's happening in terms of the hydraulic fracturing space. Another thing is improppant. So there's going to be usage of not just 100 mesh. That's the most recent usage of proppant in the Permian Basin, where you use 100% 100 mesh. But you also have micro proppant, which is even smaller to have even those fractures. So even if you're flowing back your wells, that micro proppant is going to stay in those fractures and will enhance production. There's a few companies that have touted micro proppant to improve their production from the hydraulically fracked wells. I think I gave a lot of ammo in this Musings Monday in terms of hydraulic fracturing and all the latest and greatest technologies that come from it. One of my suggestions when it comes to hydraulic fracturing or to learn more about it is to definitely attend the HFTC conference that is provided by SPE, or Society of Petroleum Engineers, the Hydraulic Fracturing Technology Conference. That's usually held in end of January, early February every year. So I would suggest going to that. There's also a technical section for hydraulic fracturing that I would suggest to join from SPE's technical section. So go ahead and go to the SPE website and search for technical sections and find hydraulic fracturing in there. There are monthly talks that are virtual that you can definitely sit in and listen to that as well. Those are all the things that I can think of right now. And I will go ahead and put some resources in my Mensan Musings Monday to talk about what more can we explore in hydraulic fracturing. This is Yogesh Pradhan. I also go by Yoshi Pradhan, also on the market, and I'm signing off.